Hi guys, back with another video. So what we're dealing with now is grade 10 trigonometry. So if we read further, it says in the diagram below, we've been given a specific triangle QPR. It is a right angled triangle and they tell us that angle QPR is 90. So we know that angle QPR, okay, they say is 90 degrees. Perfect. Now they say use the sketch to determine the ratio of tan 90 minus r. Okay, so now we need to know the different angles, right? So we don't know the size of Q, we don't have the size of R, but what we can do is we know that this is angle R. So Q has to be 90 degrees minus R, because if we take angles in a triangle, you would take your P of 90 degrees, you'll add your R, and you'd add your Q. And then to get Q alone, what you're then going to do is take the other two to the other side, leaving you with 90 degrees minus R is equal to Q, because 180 minus 90 is 90. So technically they are asking us for 3.1.1 to solve for the size of angle Q. Alright, so PQR. So in this case, tan of 90 degrees minus R. Now remember from SOHCAHTOA, okay, we have SOHCAHTOA. Our tan is opposite over adjacent. So tan 90 minus R is actually equal to our opposite side of our angle, which is PR, over our adjacent, which is PQ. All right. So that would be the ratios, just PR over PQ. Now they say write down the trig ratio that is equal to QR over QP. So if we look at QR, okay, that has to do with the hypotenuse. So can you see that tan cannot work? Because tan requires you to have a hypotenuse. So we are saying QR, all right, over QP. Great. Now, QR is the hypotenuse, all right? So for 3.1.2, QR is actually your hypotenuse. And we know that QP is our adjacent. So we have H over A, which is the opposite of cos of that specific angle. Therefore, the inverse of cos, thus your final answer is then going to be sec of 90 degrees minus R. Okay, and then that would be the trigonometric ratio that it comes in. That is your H over your A, which is then sec. Okay, I hope this was helpful. Please stay tuned for the next video.